Sunshine Gardens determines the following demand function during early summer for tomato plants. So we have our demand function is equal to 2x plus 300 divided by 10x plus 11, where Q is the number of plants sold per day when the price is X dollars per plant. And we have a picture here, a graph of what this function looks like, what the demand function looks like, where X is price in dollars, and then our demand is the number of plants sold per day. We want to find the elasticity. So in our elasticity formula, we do need to have the derivative. So here we need to take the derivative of the demand function. Notice we do have a numerator and a denominator. So when we take the derivative, we are going to have to use the quotient rule. So d prime of x is going to look like, first we take the denominator, which is 10x plus 11, times the derivative of the numerator. The derivative of the numerator is 2, minus the numerator, so minus a 2x plus 300, and that's multiplied by the derivative of the denominator. The derivative of the denominator in this case is 10. And then quotient rule, we divide by the denominator squared. So we have 10x plus 11 quantity squared. So now we need to simplify this. We're going to multiply the numerator out, so we have a 20x plus 22 minus 20x minus 3,000, all divided by 10x plus 11 quantity squared. When we combine like terms in the numerator here and simplify, we get our 20x and a minus 20x drop out. So we have 22 minus 3,000, which is going to give us a negative 2,978 divided by our 10x plus 11 quantity squared. So now next let's calculate our elasticity of demand. So E of x is, we take a negative x times the derivative, which we found to be a negative 2,978 divided by 10x plus 11 quantity squared. And then this is all divided by the demand function, which is 2x plus 300 divided by 10x plus 11. So now let's simplify this. So what we have here is, on the numerator, we're going to have, we've got two negatives, a negative x and a negative 2,978. So the negatives are going to cancel, and we're going to have 2,978x divided by our 10x plus 11 squared. I'm going to turn this into multiplication and flip the numerator and denominator of our denominator fraction here. So I'm flipping this numerator and this denominator. So we're going to have 10x plus 11 divided by 2x plus 300. So now our 10x plus 11 in the numerator is going to cancel out with one of these on the denominator. Additionally, we have 2 as a common factor in the numerator and denominator. 2,978 is divisible by 2, and we can also factor a 2 out of our 2x plus 300. So if I factor out a 2 out of 2x plus 300, we have x plus 150. And then if we factor a 2 out of 2,978, we have 2 times 1,489. So now this 2 in the numerator cancels out with the 2 in the denominator. So this simplifies quite a bit here. So now what we're left with here is 1,489x in the numerator, and then in the denominator we have a 10x plus 11 times x plus 150. Alright, so there is our elasticity of demand function. So next in part B, we want to find the elasticity at the price x equal 3. So we're plugging 3 in for x. So we have 1,489 times 3 divided by 10 times 3 plus 11 multiplied by 3 plus 150. Alright, so this is 4,467 divided by 6,273, which reduces to 1,489 over 2,091 when we divide both the numerator and denominator by 3. Now here this is less than 1. So since e of 3 is less than 1, this tells us that the demand is inelastic. So that means an increase in price will bring an increase in revenue. So when the demand is inelastic, the revenue is increasing. So to answer part C, at $3 per plant, will a small increase in price cause total revenue to increase or decrease? Well, we just got done saying that since the demand is inelastic, then revenue is increasing.